Hello everyone. In the previous slide, we have discussed about the JK flip-flop. So what was the problem in the JK flip-flop? The problem was race around condition. That means if J equals to 1 and K equals to 1, what we are getting? The output was toggling. Okay, so to prevent that race around condition, we have discovered the master slave JK flip-flop. Okay. Now before going to the master slave JK flip-flop, we must understand what is race around condition. So I have written here, if J equals to 1, K equals to 1 and clock pulse duration is long. As you can see here, the clock pulse duration is long. Okay. Then the output keeps on toggling like 1 to 0, 0 to 1, 1 to 0 and so on. See, if we are predicting the output, that means if the output is 0, it will toggle to 1, then 1 to 0, 0 to 1. Okay, I have given this toggling in the next slide as well. I will explain you in the next slide. This leads in uncertainty in determining output state of flip-flop. This condition is known as race around condition. Why this condition happened? Because in JK flip-flop, if you remember, there was a feedback to the input. That means if the feedback is if the output is changing and then again the output is going to the input, which is again changing the output. You understand this thing? The output is feedback to the input. That means the output is going to the input, and then due to that change in input, the output is again changing, and then again this output will go to the input, and then again the output is changing. So that means the output starts to toggle. Toggle means 1 to 0, 0 to 1. So that was the main problem in the race in the JK flip-flop, and this condition is known as race around condition. Now to prevent this condition, this JK flip-flop is discovered. And this is a very important flip-flop, very important, and you must see here, like in this diagram. By looking at this diagram, it seems to be difficult, but it is not difficult. It is very easy to draw. As you can see here, this is one JK flip-flop. As you can see, 4 NAND gates, 1, 2, 3, 4, same like the feedback to each other here. This is another one, the same JK flip-flop. This is a clock pulse here, that is a clock pulse here, and the output, like here, this output is feedback to the, this output is feedback, as you can see here, and this output is feedback to the one of the input of this NAND gate. So it is very easy to draw. This is one JK, this is another JK, and the output is feed as in the JK flip-flop. Okay. The main important thing to notice in this one, the clock of 2 JK flip-flop. As you can see, this clock and this clock, this both are connected with a inverter or a NOT gate. What does that mean? It means if a clock pulse is high, that means if I am applying 1 here, then at that time this one is going here, and due to this NOT gate, this 0, we will get 0 here, and this 0 is going here. So if the clock is 0, this will not work. You understand? This flip-flop is not going to work. Only at a time this flip-flop is going to work, because the clock pulse is high here. So only this flip-flop is going to work. Okay, so at one time only one flip-flop is going to work. As I have mentioned here, one flip-flop is going to act as a master flip-flop, and another one is going to act as a slave flip-flop. Why? Because one is following the another one. Okay, so basically it is a combination of the 2 flip-flops. One act as a master and another act as a slave. So basically, if you remember, the toggling condition comes when J equals to 1 and K equals to 1. So if we see, just concentrate, if we see J equals to 1, K equals to 1, and the clock pulse is also 1 here. Okay, so if we assume the output is coming here 1, okay, see, suppose the output is 1 here, That means at that time when the clock pulse is high, this is not going to work. That means there is no feedback. There is no feedback which is going here. Understand this? That means the output, whatever the output you are getting here, whatever is the output, it will remain the same output. It will not toggle. Why it will not toggle? Because this flip-flop is not working at that time. So if this is not working, this output will not be feedback to the input of this. So it will not change my output. So at that time when the clock pulse is high, only this master flip-flop is going to work and this is not working. So the output will remains the same. It will not toggle. Okay, and in the next clock pulse, like the clock pulse is like low to high and then high to low. So if it is a negative cycle, that means it is 0 here and this is 1 because this is a NOT gate here. So it is not working, it is working. So whatever is the output here, it will go here, and whatever the output you are getting, you know the working of the JK flip-flop, you can determine the output. Whatever the output you are getting here, it is not going to feedback here. So whatever the output you are getting, that will be the output for that whole cycle. It will not toggle here. This is the toggling condition. I have shown here the toggling condition. See, the clock pulse is high. The clock pulse is high means the clock pulse is long duration. You can see the clock pulse is very long. So at that clock pulse, the output is toggling 0 to 1, 1 to 0, 0 to 1, 1 to 0. So it is really very difficult to determine the output, that what is our output, because it is changing at a very fast speed. Because if we are getting the output 1, then again there is a feedback, it will go into the input and it will change the output. Then if we are getting the 0 output, again it will go into the input and it will change the output, it will change to 1. So if the clock pulse is high and of the long duration, it will change, it will toggle. So that is really not possible case. That is not really we want it. Okay, so that's why the master slave flip-flop. So if we apply the master slave, as I told you, at a time only one flip-flop will going to work. As you can see, if it is going to work, this slave in the off state. So if it is in the off state, there is no feedback coming from anywhere. So this has no importance. This has no importance. So whatever we are applying, we are getting here. Whatever we are applying, we are getting here. Okay, so in the positive cycle, when the clock pulse is 1, this will work and this will not work. So we are getting the output and that will be valid for the whole cycle. As you can see, it is not toggling. Understand this? And in this one, when we apply, when in the negative cycle here, in the negative cycle, this master will be in the off state, only the slave will work. So if the slave is working, there the output you can see, the output is not feedback to the master one. So basically the slave is working, so whatever is the output we are assuming, or we are taking, that will be the final output. You understand this thing? So it will not toggle in the negative cycle as well. So this is total all about the master slave flip-flop. Remember why master slave flip-flop is used: to prevent the race around condition. And what is the race around condition? The race around condition is if J equals to 1, K equals to 1, clock pulse is 1, then there is a toggling of the outputs. That is the race around condition. So to prevent that toggling, we have used the master slave flip-flop here, and in this you can see the difference in the output, and we have taken the long clock pulse and you can see the difference in the output here. I think this master slave is clear to you now. In the next slide, I will discuss the D delay and the T toggle flip-flop all together. So D and T flip-flop will be covered in the next slide. Thank you so much.